The binding of a substrate to the active site of an enzyme produces an enzyme-substrate complex that is held together by one or more means, such as hydrogen bonding, electrical attraction, or temporary covalent bonding. Enzymes are superspecific because of their exact three-dimensional shapes and the chemical properties of its active site. Only a narrow range of substrates with specific shapes, functional groups, and chemical properties can fit properly to bind to the active site. In this example, we can think of an enzyme as an auto shop and the substrate as a car. If your car is having tire troubles, you can take them off yourself, but it will take you a pretty long time. Instead, you head to the auto shop to have the reaction catalyzed and your tires taken off faster. This type of reaction, in which a larger molecule is separated into smaller molecules, is a catabolic reaction.
Competitive inhibition is a form of enzyme inhibition where binding of the inhibitor to the active site on the enzyme prevents binding of the substrate and vice versa. Most competitive inhibitors function by binding reversibly to the active site of the enzyme. For competitive inhibition, we have the same setup. A yellow Perkins space that represents an enzyme, and two cars that represent substrates. The two cars race towards the Perkins site, but only one, the blue one, enters, causing the orange one to drive away. While the orange one is driving away, the blue reacts in the enzyme.
Non-competitive inhibition is a type of enzyme inhibition where the inhibitor reduces the activity of the enzyme. A non-competitive inhibitor can bind to an enzyme and change its shape as well as its active site. This makes the substrate unable to bind to the enzyme effectively. In this example of non-competitive inhibition, the owner of an auto shop came into a shop and closed down so that no other cars could come in.
Allosteric regulation occurs when a non-substrate molecule binds or modifies a site other than the active site of an enzyme, which is called the allosteric site. The binding of a molecule to the allosteric site causes the enzyme to change its shape. The change in shape alters the chemical attraction of the active site for the substrate, and so the rate of reaction is also changed. Allosteric regulation can result in the activation of a formerly inactive enzyme, as depicted here. We can think of it as a shop owner reopening his store for business. The blue car is the owner of the shop and represents a non-substrate molecule that binds to the allosteric site, thus opening the shop to customers like the orange car, which represents a substrate that can now bind to the active site, allowing a catalyzed reaction to occur. The reaction that occurs here is again a catabolic reaction.
Feedback inhibition works by deactivating an enzyme using the product of the reaction the enzyme catalyzes. For feedback inhibition, we see two cars moving towards a Perkins spot. A reaction occurs as one car enters the Perkins spot, but although the reaction occurs, the body of the car still stays inside the enzyme, causing the second car to drive away.
When an enzyme becomes denatured, it has lost some of its original properties. Denaturing can occur because of heat or from chemical reactions that have rendered the enzyme inactive. In this example of denaturing of an enzyme, an auto shop goes out of business and gets demolished.